Thanks everybody for joining today. I know this is the last session of the day, so we'll try to make this a little entertaining. For those of you that were at the open session earlier, we had some good discussions, and there was a lot of talk about different kinds of technical debt. One of the pieces that I'm really going to highlight in this talk is what it looks like at the end of the rainbow, or what are some of the other factors that we are trying to get to as we remove technical debt. How do we want to see our organizations improve? As we step into this, could I get a quick show of hands for anyone that has a Coinbase account right now? Okay, we've got a few people in the audience. So this will be near and dear to how we're protecting and securing your environment. For those of you that haven't seen Coinbase before, we're one of the largest cryptocurrency companies in the world. And what that means for us is we're in a space that's evolving really quickly, and security is very core to everything we're doing in our environment. We've recently started expanding to the UK, so we have a small office nearby that I'll luckily get to spend a little bit of time on this week. And if you haven't seen our platform before, this is what it looks like. So this is our GDAX exchange. One of our investors is the New York Stock Exchange. And this is actual money moving through our servers. We've scaled up quite a bit over the last several years. I've been at the company for around 3 years. And this is not just a ticker in a ledger. This is real cryptographic money moving through our services. So we have a large and concentrated store of value that we spend a lot of time thinking about how do we protect. We look at a lot of metrics in our environment as well. So from when I've joined the company in 2014, we've since scaled from 1 country to about 33 countries today, and we have large growth plans for later this year. I think that number will tick up quite a bit. We've grown to about 6.1 million users, and I think really interestingly has been the growth of services. There have been a lot of talks at QCon about monolith to microservices, or what does life look like with microservices. But one of the other sides to growing the number of services that we have is also the technical debt and the complexity that it takes to properly manage all of those services. When I joined the company in 2014, we had one monolithic service that was Coinbase. We've since scaled up quite a bit to now running over 100 services today. And I'm going to pull back the veil and share what some of those growing pains have looked like and what are the tools we've built to manage the technical debt associated with them. The last metric that I'll expand on quite a bit is the number of deploys per engineer per month. So this number is actually the average amount of deploys per engineer per week that we want to see in our environment. We strive to have the median engineer in our engineering team deploy about once per day per week. We try to avoid deploying on Fridays to avoid incurring weekend debt, but right now we're deploying on average our median engineer about 4.5 times per week, and we're really proud of that statistic. For the overall industry that we're a part of, we think we're trying to accomplish a fairly large mission. The mission at Coinbase is to create an open financial system for the world. And a lot of where Bitcoin has been shared in the press and where there have been articles written about us have been the large spikes and the booms and the busts. And if we were to focus solely on those, we wouldn't have a large challenge in front of us. What we're thinking about is how do we connect this new technology to the rest of the world? So there have sure been some large spikes over the past. We're currently right now at an all-time high in our industry, which means we're seeing more load than we've ever seen in our environment before, and we're very proud of that. But we're really thinking about the long term. We're thinking about not how does the market cap grow incrementally, how does it grow exponentially? And so as we're designing our services inside, we're not thinking about how do we get twice as large. We're thinking about how do we grow 10x? And how do we ensure that we don't introduce technical debt today that puts handcuffs on our team and prevents us from reaching the scale we eventually would like to see ourselves at. Following that moonshot mission, for those of you that follow cryptocurrency on Reddit, there's always been the to the moon guy, where whenever something large happens in the industry, you'll always see this person comment on that thread inside of Reddit. And we think a lot about how do we design for truly massive change in our industry, and that's really why we're all at Coinbase today. So I deeply believe that moonshot players are powered by engineering velocity, and the reason we're all here today is because I believe we will fade away with technical debt. If we cannot maintain velocity to iterate faster than other people in our spaces and grow as our environments do as well, we simply cannot survive. And so I'm going to talk a lot about how engineering velocity can be looked at, measured, and improved inside of our environment. I've split this talk up into roughly 3 sections where I'm going to start on that topic of engineering velocity. I'm then going to talk about some of the unique things we've done in our environment to fundamentally architect out debt from our environment. And I think a lot of the lessons we've learned are applicable to other environments. And I'm going to finish with a recent test that we ran that we called Scorched Earth to exercise the components of our architecture that we think help aggressively remove technical debt from our world. So starting with engineering velocity, could I get a quick show of hands for anyone that's ever worked in the government? Okay. Could I get another show of hands for anyone that's worked in finance or some heavily regulated industry? The majority of the room. Okay, so I think this is a telling sign where I've worked in these environments too, where you show up to work and we want to be empowered engineers. We're here for a mission. There's something we want to ship out to production, but there's some slow or bureaucratic or churning process that just prevents us from getting out to production. And this may have come from a reasonable place. Maybe there's enough technical debt that there's real fear or there's the potential for a catastrophe if we ship the wrong thing at the wrong time. But this is what we have to fight against. We need to create an environment that engineers feel empowered in and want to work quickly for. For those of you that have ever worked through an engineering change request process, I found this online for one of the large enterprise business suites that I think you'd all be familiar with. And what this does is detail all of the steps required to make a change through a software suite that they share. And if we break this down into a linear step to simplify this a little more, this starts with the manual process on our tool of creating forms. This then encourages us to make the documentation, which based on the system they're using here, I'm positive is a manual step. They then encourage you to redline, and building on that system is a third manual step. Then you have to go out and get signatures, and they mean the physical kind here. And only then can you do work. Think about all those barriers to adoption or the barriers for a great idea to find its way into life. And after that, you can go through their release process. And what really kills me is that throughout our industry, this is really popular. This can be the norm for how a lot of us do business. The presentation this was shared and online had almost 90,000 views. I don't suspect we'll get that many on this presentation, but if we can share these ideas and start to fight against the manual sludge that prevents our creativity from finding its way into production and encouraging engineering velocity, I think we'll have made a great impact. Where I think this kind of process is especially harmful is a quote I picked up from actually my first job, one of my first jobs ever at a car wash, where they impressed in us that when a customer has a bad time through our experience, the majority of the time, they're not going to complain. When someone has a frustrating time in our infrastructures or our environments, I think the same holds true. And the majority of them, frustratingly, will never return. So we're not going to get the feedback that there's a potential issue in our pipeline. And sure, we can do things to improve that, but fundamentally the default state is we won't know when there are large problems, and this is going to pull people away from sharing ideas or away from trying new things. And coming from the government where I worked in the past to now at a reasonably large financial startup encumbered by a lot of security regulations for a good reason, I've come to deeply believe that the velocity that we need to create is what helps our environments evolve. And for those of you in a startup or someone that's not printing money or having a full monopoly over your business, we need to continue evolving to survive. And it's technical debt that prevents us from turning that velocity into evolution in production. I want to rewind over the last few years in our environment where this is what Coinbase looked like in about 2012. So we started as a company that was trying to bring Bitcoin to the masses, and we started as a hosted Bitcoin wallet, we called it. We realized that people didn't always know what that meant, so we then pivoted to now focus on making Bitcoin easy. We then, as you can tell, hired a designer and wanted to make it simple, so now we were Bitcoin made simple. We then became Bitcoin safe and easy. This is after there were some very public security incidents with other players in the space, so we started to focus on security. And all the while, behind the scenes here, this is where we're starting to grow from one service to now 10 services, and now 30 services. Our design team then had some other refactors in our environment. We then became the place to have a hosted Bitcoin wallet. And right around this time, we realized there was another large opportunity in our space to not just provide a tool for consumers, but to also create an underlying exchange. And that's where that tool, GDAX, which is now another brand of business for us, came from. This represented a massive shift in our internal infrastructure from starting to migrate off of Heroku and third-party services into an AWS environment that was much higher performance, moving much faster, and much, much more secure. From this point, we've started to spend a lot of time recently on scaling. Around the time of the last screenshot, we had a couple million users. We pretty quickly from there shot up to 3 million, 3.3 million. Around this time, we also branched outside of just Bitcoin, and we're now servicing multiple cryptocurrencies, which was also a massive shift that migrated us from a lot of technical debt, from assuming there was only ever one pair, to now supporting multiple cryptocurrencies like Ethereum. From this point, we then focused on scaling quite a bit. So we're now up to about 6.1 million users and growing now faster than we ever have. As of yesterday, we were seeing the highest loads on our website and databases that we've ever seen, and we think that's going to continue scaling. And it's having engineering velocity that helps that proceed at a fast rate. Over this period where evolution has been especially valuable for us has been watching the rest of our space evolve. This is a snapshot of some of the other players in our space and some of our competitors a few years ago. Fast forwarding to today, most of those companies don't exist anymore. And I think our investment in developer velocity and developer experience has really helped us survive and continue to thrive. So looking at some metrics in our environment on what that's looked like over the past year, we move fast, we launch a lot of servers, we deploy really frequently. Quantifying that, we've launched almost 150,000 servers last year. We deployed over 13,000 times. This is just 2 production successful deployments. And we've created about 45 new services in that period. And we're really proud of that velocity. But following one of the points I brought up at the beginning, we think this velocity is only at the beginning of the growth we're here to see. Looking at some of the other large financial networks, Visa today is processing around 2,000 transactions per second. PayPal is processing around 155, and Bitcoin's only processing around 3.5. There are a lot of wild ideas and new cryptographic primitives that we think will help us scale to the volumes we'd like to see, and these are going to represent other massive shifts. We're not sure what they'll all look like, so we have to design for an uncertain future and design with flexibility in mind. I think engineering velocity really requires 2 pieces under the hood. The first are the tools that we can build and provide our engineers, and that can be broken down into a number of components, but also the guardrails. So as people are deploying into production, we don't want to constrain what they can do or how they can do it, but we want to make sure it can only be done safely. Security for us cannot be an afterthought. It can't be something we look at reactively once something's in production. It needs to be a core part of our pipeline, so security is what enables us to work, not something that disables us. By default, we are not able to work in our environment, and it is the tools and the guardrails that security provides that allows us to move productively. One of the first pieces I'm going to start breaking down is shipping. So we have a strong culture of shipping at Coinbase. That is a key word. That is what our founders value. This is something we emphasize heavily. And we emphasize this because we believe stagnation is a form of debt. If we're afraid or for whatever reason unable to push changes into production, that's often a great indicator that there's some kind of debt in our environment. And we spend a lot of time instrumenting to measure what shipping looks like. I want to talk about our evolution from the early days of the company, where we started on Heroku, which was a great enabler to help us move fast. Deployment was very easy. One line of code would allow us to deploy, and the environment was entirely managed for us. When we were running on Heroku, we had a reasonably small engineering team, and this chart is showing the number of deploys per engineer per month. And what I want to point out here is that the bottom 3 engineers, where we have a number of other engineers grouped up into the light blue on top, but the majority of our deploys were pushed out by 3 engineers. Our engineering team was much larger, but only a few people had the permissions to use this tool because that one line was so powerful. If you had that deployment access, you generally had access to do just about anything inside of our environment. We then invested a lot of time building internal deployment tooling, as I think almost every shop here has done at some point, building your deployment tooling as you build in your cloud or your environment. The tooling that we built had a strong emphasis on a more powerful permission model so we could expand the number of people that were empowered to deploy without having to tap another engineer on the shoulder. So they felt that their changes, the things they wanted to push out to production, they wouldn't be stopped and they wouldn't walk away dejected and perhaps not let someone know, but they would have their own way in a codified pipeline to push that out. So as this tool, CodeFlow, came into the wild at Coinbase, what we saw was a massive increase in the number of engineers that were able to deploy to production. So this is the month where we first started to release CodeFlow for our internal services, actually the month we deployed our Coinbase Exchange, or GDAX. And the all others became our greatest source of shipping to production. We were really proud of this. This was removing our lead engineers or some of our leadership from being the only people trusted to hit that deploy button and creating a codified workflow so everyone could start tackling some of the debt in our environment and preventing other ideas from not shipping out to production. In order to ship effectively, there are a few tenets that we've invested in and we deeply believe in. One is, in order to make this a core part of your environment, everyone needs to be able to deploy your tested master to production. Once we've gone through tests, we've gone through our guardrails, we want to trust those guardrails, and we allow anyone to then push those changes that have passed our guardrails out to production, period. We then believe production deployments start on your first day. We want this to be a very fearless process. We want our engineers to feel comfortable pushing even our largest services out. So on your first day at Coinbase, we walk you through the process to make a change and hit the deploy to production environment. We want people to be comfortable deploying to this environment. And lastly, having a blameless culture. We spoke about blame a little bit in the open session earlier today, and that's a word that we really don't like. We think when there's a failure in production, it's a failure of guardrails, it's a failure of automation. We never blame an engineer. We do not want that a part of our culture. Accidents happen, sure, but if something breaks, we're going to learn from that in the form of better automation or better testing or better health checks and continue improving. Just like the Boy Scout rule that was mentioned earlier, we always want to leave our environment better than we found it, and we do not ever want to have a blame culture. Fast forwarding a little bit further to what deploys have looked like as we've scaled since we've migrated onto this new deployment system, you can see our large spike as we migrated off of Heroku and we're able to start democratizing access to our production environment. You can then see other engineers starting to join the company over that period. You can see Mr. Green here start to contribute to other services inside. And so this chart roughly mirrors the increase in services and staff that we've seen over time, and we're really happy to see that number going up and not stagnating as more security and regulation comes into our financial space. When we overlay the price of Bitcoin over this, so this is showing roughly in a scale of GBP how valuable Coinbase or how valuable Bitcoin was over this time, we see it growing a little bit, but we don't see a big exponential growth. What we see ourselves spending a lot of time on is improving our infrastructure and preparing for big changes. And it was a lot of the work that happened in this period, preparing for scale, preparing for flexibility, that's allowed us to survive and handle some of the load we're seeing today. And it gives us a lot of confidence that as our environment and constraints change around us, we'll be able to adapt to those as well. Poking a little bit at the guardrails I mentioned before, not all of our deploys to production succeed, and that's a good thing. We want engineers to make changes that may not always succeed in production. What these mean are our guardrails are working. So when we deploy something out to production that, for whatever reason, is not going to succeed, maybe there is a untested database query, or we're missing an index, or something's unique in production, we have robust health checks that will see that roll out, and if there's a failure or performance degrades, or we're not seeing the same characteristics that we'd seen on a last deploy, we'll fail that deploy, we'll roll it back, we'll call that a successful usage of one of our guardrails, and we'll provide feedback to an engineer to say, hey, this didn't work for some reason. Maybe you weren't aware of some debt in some other part of our code base. Maybe there's some dark code in another place that caused some issue here, and we'll start to walk them through it. So rather than being in an environment fearful of that, where we're afraid to push something out, this allows us to move fast, embrace some failure in our environment, and still work safely. And these are some of the shipping metrics behind our growth of services. Today, we're running at about 105 services in our environment. And so as that number continues to grow, I think that follows closely Conway's law, like we saw from the last speaker. And by breaking into more services and providing the tools to do that effectively, we see ourselves increasingly lopping off debt, turning that into a new well-defined service, and increasing our velocity from service to service and deploy to deploy. One of the KPIs that we look at alongside of this is that metric I mentioned, deploys per person per month. This is a really valuable metric for us to assess the debt and the fear and the overall productivity in our environment. And we expose this on our weekly retrospectives for our infrastructure team and the rest for engineers as well. This is a metric we want to share with our teams. This is not something used by management to objectively evaluate how we're working. This is something we want to use to encourage our staff to build the systems to maintain their velocity. The target metric that we have is about 4 deploys per person per week. We recognize all weeks are not the same, so we look at that over a monthly basis, and we target 16 deploys per person per month. Coinbase varies from about 3 to 6.5, looking over the last year and a half or so. I attribute that variety to new services coming online or new design periods where we may not have been deploying to production as often as we have in the past. Some of the constraints we look at here are only successful deploys, only to production, and only new commits. We don't measure when people are deploying to development, we don't measure deploys to staging in this metric, and we don't measure when old deploys are being redeployed out to production. This is something that's supposed to look at what our velocity looks like in how we're evolving. If we're just looking at how old things are changing or experiments are happening, that's not as effectively evaluating our ability to evolve in production, and that's really why we're looking at this, and that's the change we want to see. Some of the other big factors for us, like I mentioned, microservices, but also ACLs, access control, permissions, the ability for people to, for engineers to feel empowered to get things done is incredibly important. I can't tell you how many times I've seen environments where engineers would like something to change, but they don't have the permissions. There may not be a great reason behind that. It may be organizational bloat, or they haven't been onboarded, or there's not a well-defined process. But any time you don't have the permission to go through a process that for no good reason is not codified or automated, that's deeply harming your environment. And we think a lot about how to streamline that, simplify our permissions, and empower our engineers. And lastly, for edge cases, not everything needs to be deployed. We've shared some of these metrics online, and in the past, people have immediately called out, well, you're a financial institution, you must have services managing money or managing crypto. Are you honestly deploying those on a regular basis? Absolutely not. We have different rates of velocity inside of our environment, and that's a great thing. Our web page or our front-end services might evolve much faster than our financial processing units in the back, and that's intentional, and I think that's a good thing as well. One of the next places we look at are pipelines. So how many people have a deployment process where every engineer or every service team has a slightly different way in which they access their servers or deploy something out to production? Okay, we've got a few people. And that's a natural state to be in. It's something that evolves. It empowers engineers to give them access to their services. But this makes it really difficult to manage those services over time. So we've invested a lot in having streamlined pipelines to get things done. It helps engineers migrate from team to team to team, and it's deeply valuable for security. Where you're in an environment that has many different ways of deploying, that can be fine, but now you need to replicate your security work, some of your infrastructure work, some of your availability work. And so by streamlining your pipelines and really thinking about your components, that can be a great thing for velocity and simplicity. These are some of the components that we take a strong look at inside of our environment. And one of the big shifts that we went through was from looking at these as individual components in different services that perhaps different people were focused on, to starting to link these together and thinking of this as a whole workflow from starting with an idea, walking through all of these steps, and getting something out to production. Wherever there are manual blocks, or you have to walk and talk to a human, or you have to slow down because there's some process that's not well understood or defined, that is a problem and that needs to be addressed. This whole workflow is one developer experience, and it needs to be optimized as such. One of the projects I worked on recently was to start simplifying the bootstrapping of this process, where we originally had some documentation and some manual training where we would help get you up to speed on these services. But what we do now is we have a simple REPL with template projects for all of our default languages. If you want to start a new Ruby project at Coinbase today, you can run cf init. This will pull down a default repo. It'll have a default Docker file configured to some of our default Docker images, our default Circle test file, a git ignore file, some of the simple boilerplate to help you get up and running so we can further increase your velocity through this pipeline. This also, like I mentioned, bringing security in line has had a great boost for us, where rather than security and infrastructure and other teams coming in after the fact to say, well, you built this new service and it's great, but actually we need to use this, we can bring them into the start and make them a core part of our pipeline. This prevents a lot of the unique services or the changes from environment to environment that can start to look like debt. If all of your services are unintentionally designed completely differently, if we're not holding hands or providing services for our developers to make steps repeatable, as we go from service to service and we're trying to go from team to team to contribute across all of our code base, it's going to be really difficult. And what looks like debt to you might not look like debt to me because I'm so familiar with it. So we want to start standardizing or recommending those standards where possible. The next part of our workflow that I think is fairly common for many of us is a pull request model. We use GitHub Enterprise internally. It's worked well for us, but we all, I hope, have version control of some sort. One of the next pieces that we always go through from our pull request is then going through a code review. And there are a lot of good tools that we can use for a separate code review. There are great meeting structures that we can run these through as well. But we've spent a lot of time integrating this deeply with our workflow. So our code review is all done on our pull requests that we've opened inside of GitHub. We've built our own tooling to streamline this in line. And this is where our code reviewing and our approvals to go out to production will happen. Once we go from, once we're working on our code reviews, we'll also monitor that in line. So we have a bot that'll monitor who's approved, what's been approved. This ties back with our deployment system, so we'll see those approvers in line. We also do this for other parts of our environment. So it's very easy for us to create other dark components from your dark code, but also dark parts of infrastructure. And I've seen a lot of environments where you may want to make some change in your environment, but because you don't have the permission, you have to talk to someone in security or production or NetOps to make a change to a firewall or some other setting. So we spent a lot of time also codifying our infrastructure to turn as much of our environment as possible, or any part of your job you need to work on a regular basis. We want that codified. We want that in our pipeline. We use a tool called Terraform inside, and a wrapper around that we've open sourced recently called GeoEngineer that helps us easily codify our infrastructure so we can also code review and open pull requests to any environment. One of the metrics for success we were looking at as we started to go down this project was I wanted any intern or anyone on their first day at Coinbase to be able to open up a pull request and propose a change to a production firewall and see that process through a codified workflow make its way out to production. So this is not tapping people on the shoulder. This is walking through a well-defined pipeline. Next component of that is security. And following this streamlined pipeline, we bring that in line too. Every one of our pull requests that's open is run through some security tooling that we've created. So we'll scan for application layer issues, network layer issues, or OS or dependency layer issues. And that'll all happen directly in this pipeline. We're using GitHub status checks here. We also expose this through our deployment tooling, so it's as easy as possible to look at. By bringing this into our pipeline, this also prevents a lot of debt from forming once we've deployed or tried to deploy into production. I'm sure many of you have at some point been stopped by security where you've worked your way through a project, security comes and says, well, we don't quite want to do something that way. And it comes after you've spent a week working on it. And that can be a really destructive thing to your ability to evolve in production. We then go through a fairly normal CI process. We use Circle CI Enterprise inside, but we've used a number of services over the years. One of the pieces we've spent a lot of time on is optimizing the build time, the build speed, and especially the build queue inside of our environment. The build queue is something I think we all have a lot of effect over. It can be one of the easier things to optimize over your build times. This was brought up at Facebook's Disrupt conference a couple of years ago, where you can look at this kind of problem in a couple of ways. And often we find our humans or engineers waiting on machines. And I think that's the wrong way to look at a problem or approach a solution. And we always want to invest in machines waiting on people, not the other way around. Almost every case results in machines being less expensive than humans, and empowering our staff to not have to wait on our machines running can be something that can really help our environment. We do this for our CI cluster and investing quite a bit in a large auto-scaling group. So we're using some custom CloudWatch metrics for those of you familiar with AWS. This circle.runQueue container is a custom metric they send out to CloudWatch. We can pick that up in our auto-scaling group scaling metrics. And whenever we see engineers show up in the morning, we'll start to scale up our capacity and over provision. So as new tests come in through the pipeline, we'll have capacity ready to go. Machines will be sitting there waiting on humans, not the other way around. It helps us move fast. The next piece that I've mentioned a couple times is permissions. And permissions can be one of the most disenabling things in our environment. So oftentimes at larger orgs, the way we pick up privileges is from the time we get hired until the time we leave. We slowly accumulate permissions. We slowly get more effective. And it might be that senior lady on your team that's the most effective person in the room because she's been there the longest. Not necessarily because they're the most senior engineer or because they're supposed to have more permissions. They've just been there longer, so they're more effective. And if we're not empowering our engineers from the first day they join your organization, we're doing harm to our environment. Especially when we want to tackle debt. If we're not empowering our staff to actually tackle that debt or to make that small upgrade or slowly evolve as new services and new dependencies are released, we're going to see debt accrue across our environment. So we need to make this a part of the past of our industry, investing in good onboarding for your staff, really thinking through what are the permissions your whole team needs, making sure everyone has that permission. I spent a lot of time walking through other engineering teams at Coinbase, and I'm always asking, was there anything you were blocked on today? When you were working on this project, were there any manual steps? Was there anything you weren't able to do? And I make a note of that, and I'll aggressively go back and look at why that was the case and try to fundamentally fix our permissioning models inside. Those poor permission models can truly handcuff your best engineers. And with those handcuffs on when we can't keep our services up to date, when we can't evolve, and when we can't ship, that's where we're going to see debt start accruing and growing inside of our world. The process we follow to truly empower our engineers in a world where security is one of the most important things that we do is we follow a dual-person turnkey model, or we think of this as consensus engineering. And I truly believe that true value is secured through consensus. Humans can be single-point failures. Laptops get compromised. We see mistakes happen. And so we invest a lot in making sure no single person has access to any of our customer funds, any of our secure data, but always providing multiple people or a quorum of trusted individuals the ability to escalate permission and make a large change and have a large impact in our environment. The way this is implemented inside is in 3 phases. The first phase for a good consensus engineering permission model for us is the proposal phase. We need anyone to have the ability to propose some change to our environment. For us, this means codifying as much of our environment as possible, trying to eschew the idea of a single administrator, and having that person be able to propose a codified pull request, typically through Git, to our infrastructure, to any of our applications, or any of our source code. Okay, of course, making sure secrets are out of that. We then have a separate phase of achieving consensus. This is the consensus code review bot that I showed earlier in this process, making sure multiple people have cryptographically signed or approved that this proposed change is safe to deploy to production. And we can control that a few ways, but I want anyone to be able to propose almost anything in our environment. Security for us is in the achieve consensus phase. And lastly, I want anyone to be able to apply anything to production. If someone can't deploy a tested and passed master branch of your largest service to production, I think you really have to ask yourself why. And if it's because you don't trust your tests or your suite, that's something that needs to be tackled directly. This is a snapshot of what that looks like in our environment, where when multiple people have turned the key or code reviewed and approved a pull request, that unlocks it so we can deploy inside. Where there are novel cryptographic applications of this are where we're starting to use a lot more Shamir secret sharing in our environment. And this looks like some M of N implementation where N people are authorized and any M of those people are required to come together to unlock the key that can make great change and great impact in your environment. One of my favorite implementations of this that's open source and accessible by everyone today is with HashiCorp's Vault product. And can I get another show of hands for anyone that's using their Vault product today, for who's familiar with this? Okay, a small percentage, maybe 5% or so. So what this looks like in the underlying implementation, we end up using this cryptography for a lot of our key stores where we're storing real value in the form of cryptocurrency on our machines or in our cold storage, is with an implementation like this, where when you initialize a new vault, you define the number of shares, or that's the N of the number of people that will have access to this, and then the key threshold, which is the M. And this is saying that any two of these three shares can come together to cryptographically unlock some encrypted key that's encoding all of our data in the back end. Once we've created those shares, we'll then distribute them through some secure ceremony. And as long as those shares come back together, so what we're going to do here is post one shard and then post a second shard, that unlocks or unseals our vault, and that allows us to work. We use this for even some of our deployment processes inside, where beyond the normal vault, the vault usage, their underlying Shamir's implementation can be used to require multiple individuals to unlock a deploy, unlock a service, or create some other great change inside. We've integrated a lot of this through our deployment tooling. So this is really our consensus engineering tool, or this is our code flow service that powers all of our deployments at Coinbase. One of the next metrics we think a lot about is what our developer productivity looks like compared to the rest of the industry. And for those of you that have seen the annual Puppet State of DevOps report, I think this takes a great snapshot into how the rest of us are doing in this world. Some of the metrics they pull are how fast people are moving, how fast people are deploying, and the impact that has for public traded companies on their share price and their overall performance as a company. So one of the metrics they look at is the frequency of deploy, and they find people practicing DevOps the way they've defined it are often moving 200 times faster than their other competitors in the space. And 200x improvements is a great enabler for our ability to change. Looking on the top right for 24x faster recovery times from failures, that is absolutely critical to tackling debt in our environment. If we can't respond to it quickly, it's going to keep accruing. So that kind of velocity is really important for us to keep debt out of our environment. The next thing we find is we all want to bring great people into our environments, and this is something that helps us continue to evolve quickly. And we find that in high-performing teams that are moving faster, they're nearly twice as likely to refer good people into their environments, so also a great thing for our growth. And lastly, for security, 50% less time remediating security issues. It turns out most security issues are not wild or sexy nation-state issues. They're often simply not having patched or updated your libraries, and these are things that we can truly address. So working in the world of finance, DevOps can be a bit scary as well. We've referenced publicly on our homepage, we've moved about $6 billion in cryptocurrency through our infrastructure today. And this kind of velocity that allows us to remove debt is often at face value incompatible with a truly secure world where we want to apply DevOps and automation. So I decided to take a look recently on what DevOps and security look like in the growing space of fintech. So the way I took a look at this was through a new tool that I shared recently on GitHub. This is github.com/Witoff deploy velocity. And what this is looking at is for home pages of sites that are published online, and it's pulling all of the HTML assets that they've shared publicly. So if you look at our site, whenever we push a deploy out, you'll see a new static asset hash change. And you can roughly see when a lot of modern websites are deployed, static assets will be cached based on some hash ID. So I ran this for the last month and looked at some of the other players in our space. And I was looking at how often are they deploying to production, or how often are some production assets changing. Now, this is a very crude metric. It has no insight into the internal workings or the backing services. It's purely looking at one service or one web component of these people's environment. And we found that there's a fairly large spectrum of deploy velocity or deploy rates over this month. But we see some of the largest players on top are deploying most frequently. I think there's a strong correlation component to this, where larger teams are often naturally deploying faster, but where security is so core to what we're doing, seeing ourselves near the top on this list is a good indication that we're doing something right here. We then took this, and for all of the people deploying in this phase, we're all cryptocurrency companies, so you can all see the amount of money we're moving publicly on our sites. So we can see this for many of the other players in the space as well, and we mapped the deployment velocity with the amount of money that they're moving through their environments. And we see here pretty strongly that the largest performers or the best performers publicly in terms of funds move are all deploying at a reasonably high rate. And where security is so core for what all of these teams are doing, this is something we were really happy to see. Where we're working in a debt-filled environment, there's this challenge we can also run into of unintended velocity. So where we cause some public outage or some public issue or a high severity issue, and we've had our share of these recently as well. And I think when the right guardrails are not in place, it's easy for debt to catch up with velocity and cause real problems, and we have to be really careful about this. We saw this happen to one of our internal services recently that I'm going to walk through, where this is our change list of history of deployments out to production for this service, and we deploy reasonably frequently. It turned out for all of these deployments, we hadn't yet integrated this system with the rest of our pipeline. And so what was happening here is we were building a Docker image, it was going through security scanning, and then we were deploying out to production without any form of CI in the service. It was a component of legacy that had been grandfathered into our environment. And it turned out there was a breaking change that was made. This was deployed out to production, and for about 48 hours, this service was only spewing errors and it was completely offline. And this was especially bad because when this was deployed, where we normally have HTTP health checks and we're monitoring for the state of a service reactively, and ideally we want to proactively test our services, but this is reactively, we were also not monitoring for the state of that service. So because we were missing those proactive and reactive checks, this service went offline without a warning for nearly 48 hours. And this happened because we encouraged our engineers to move fast, trust that we have the guardrails in place, and in this case, we were missing those guardrails. This was not the fault of the engineer, this was the fault of the guardrails not existing in the right places. So the way we were able to carve ourselves out of this problem without going through and refactoring the service, what we did was we wrote some functional tests that were not looking at all the incremental changes. What this is doing is in our CI system, it's booting up the whole service, it's making sure the service is failing with the correct error in our development stage. So we now see these failures in our CI system without reactively pushing them out to production. So one of the ways we find ourselves maintaining this velocity and digging ourselves out where there are still components of debt inside of our environment is making sure we have a good test phase proactively in all of our services inside. Those safe guardrails are also really important for the rest of our services and making sure we've reached 100% of our environment inside. So where we have a high functioning team and we're moving really fast, we find ourselves racing around corners, deploying new features, and then things break. And this is natural, this is a good thing. We don't want our engineers afraid of moving at this pace. We want to build the guardrails to make it safe. I think having debt in our environment often inspires fear, and we need to build guardrails to contain that fear. We don't need to put barriers in place to slow down our engineers. It's the job of your infrastructure, your DevOps, your security operations team to build those guardrails to keep your world safe and automate really aggressively. And making sure you have a blameless environment inside. I really want to emphasize that guardrails fail with debt, people do not. In this next phase, I'm going to talk a little about how we've fundamentally started architecting debt out of our environment. So I think a lot of this comes with these things called snowflakes. So a quick search on GitHub for no idea why this works results in hundreds of entries, right? How many people have that service inside your environment where your founder spun it up, somebody that doesn't work at the company anymore has spun up that server, and you're not quite sure if anyone really understands how that works? Yeah, I'm seeing some heads nods. This is a fact in our industry. This is how a lot of things work. And we're often afraid of these for good reason. You're never sure in technology when a small change is going to take the whole world out from underneath you. okay? And this is huge for security. Like I mentioned, security incidents don't often happen because of nation states or 0 days or some wild paranoid world that we're all living in. Looking at the Verizon data breach investigations report, where they profile thousands and thousands of leaks every year, they found 99.9% of them happened because a CVE or vulnerability had been made publicly available and was available with a patch for over a year, and you simply hadn't patched. And this is unacceptable, and this is something we can all work on in our environment. One of the core things that we do to fix this is our 30-day fleet rotation service. What our 30-day rotation is saying that we do not allow virtual machines or servers to live in our environment for any more than 30 days. We're constantly rotating them. We're constantly moving through them. So no server lives for more than 30 days in our environment. This is what works for us. This, for us, is a huge forcing function for automation, where we have that Snowflake server that we're afraid to change because we don't have the right testing or automation on it. This forces us to redeploy that once a month, every month, month after month. And every time, following the Boy Scout rule, we're always making things a little bit better, working towards greater automation. This is always exercising our deployment muscles, so when something breaks, we're confident that we can respond to it, and we're removing that fear of change inside of our environment. You will always accrue debt if your teams do not feel empowered to change it, and this is really empowering for us. And lastly, this sets a minimum velocity. If we're always deploying at least once a month, we have this constant habit of moving and evolving as a company, and we want to set that tone so our team knows that it's okay to change, it's okay to move fast, and it's okay to change as our industry does as well. This is a chart of what our internal fleet age looks like. This is a metric that we track, our team looks at least once a week. On average, our server age is around 24 to 48 hours at Coinbase. When I took this snapshot, we peaked at around 10 days for the median age of our server. So we're constantly burning and churning, and we share this metric in a lot of places in our environment. So we're constantly showing those percentiles. This is from one of our internal deployment tools. The way we're able to accomplish this is with strong blue-green deployments throughout our environment. So we run everything in Docker containers, but we don't yet schedule or orchestrate our containers, largely for security, but also for availability here. So we're only running mutually trusted containers on the same host. Whenever we deploy a service, they're all in their own auto-scaling groups, and whenever a new deploy goes out, we'll bring up a new auto-scaling group, make sure it passes health checks, and tear down all of our old servers. So we're constantly redeploying our boxes. This is easy for 12-factor apps, but we're also able to do this with a little bit more tooling for our databases as well. So a deploy of Coinbase.com will look something like this, where we have a lot of new auto-scaling groups going up and coming down. And the last point I'm going to mention here is, rather than reconfiguring in our environment, we're always rebuilding and we're always establishing that habit of moving quickly. I think it's key that that's an implementation detail of your infrastructure. That's something your infrastructure team can own. We don't need to impose that on all of our engineers. And this feeds really well into a lot of the serverless work that's happening today. It can be a great enabler for us moving quickly, codifying our environment, removing those snowflakes, and tying this into your world so you can get fully automated deploys. On that, I'm going to move forward to the end of the talk and note that with those architectural changes we've made and how we've architected our environment, we've really tried to make crushing debt a core part of how we work. We're constantly cycling our boxes. We're constantly rebuilding Coinbase from scratch, and it's something we're comfortable with. It removes fear, and we find it's greatly empowering for our staff. The big takeaways that I hope you can leave with are, one, that velocity can be the enemy of debt, and we want to remove debt so that we can improve velocity in our environment. We're able to do that by destroying snowflakes. Snowflakes can be the antithesis of confidence and empowerment in your world. For us, we found that our 30-day fleet rotation is a great tool to enable that. And lastly, crush the debt from your core. Having streamlined deployment processes, well-defined pipelines, and really thinking about the overall experience helps you move fast. It's great for security, it's great for productivity, and it's great for crushing technical debt. So thank you so much for joining today. I think we're a little past time, so maybe we'll skip questions here, and I'm happy to chat with anybody if you want to come up afterwards. So thank you so much.